Welcome to our tutorial on equivalent mass, also known as equivalent weight. This is an important concept in chemistry that helps us understand how substances react with each other in specific proportions. The equivalent mass of a substance is the amount that will combine with or displace 1 mole of hydrogen atoms, which is 1.008 grams, 8 grams of oxygen, or 35.5 grams of chlorine. In other words, it's the mass that supplies or consumes 1 mole of reactive units, protons in acid-base reactions or electrons in redox reactions. Let's look at the mathematical definition. If a compound has molar mass m, and in a given reaction transfers n reactive units like hydrogen ions, hydroxide ions, or electrons, then its equivalent mass, E, is equal to the molar mass divided by n. So E equals m divided by n. Now, let's look at some examples to better understand this concept. First, let's consider acids. For sulfuric acid, H2SO4, the molar mass m is 98.08 grams per mole. Since sulfuric acid can donate 2 hydrogen ions, N equals 2. Therefore, the equivalent mass is 98.08 divided by 2, which equals 49.04 grams per equivalent. Let's look at phosphoric acid, H3PO4, as another example. The molar mass m is 98.00 grams per mole. Since phosphoric acid can donate up to 3 hydrogen ions, N equals 3. Therefore, the equivalent mass is 98.00 divided by 3, which equals approximately 32.67 grams per equivalent. Now, let's look at an example with a base. For calcium hydroxide, CaOH2, the molar mass m is 74.10 grams per mole. Since calcium hydroxide supplies 2 hydroxide ions, N equals 2. Therefore, the equivalent mass is 74.10 divided by 2, which equals 37.05 grams per equivalent. Now, let's look at redox reactions. In oxidation-reduction reactions, N is the number of electrons exchanged per formula unit. Let's look at permanganate in acidic solution MnO4-, which reduces to Mn2+. The half reaction is MnO4 plus 8H plus 5E yields Mn2 plus 4H2O. The molar mass of permanganate, MnO4-, is 118.94 grams per mole. The manganese changes from an oxidation state of +7 in MnO4 to +2 in Mn2+, which is a change of 5 units. So N equals 5. Therefore, the equivalent mass is 118.94 divided by 5, which equals 23.79 grams per equivalent. Let's summarize the general steps to find equivalent mass. First, write the reaction and identify the reactive unit, hydrogen ions, hydroxide ions, or electrons. Second, compute the molar mass m of the substance. Third, determine N, the number of units transferred per formula unit. Finally, calculate E equals m divided by N. Finally, let's discuss why equivalent mass is useful. First, it simplifies titration calculations. For example, the grams of acid equals E times N times V, where N is normality and V is volume in liters. Second, it allows us to compare oxidizing or reducing power on a per equivalent basis, making it easier to understand the reactivity of different substances. In conclusion, equivalent mass is a crucial concept in chemistry that helps us understand and calculate the proportions in which substances react. By finding the equivalent mass, we can better predict and measure chemical reactions, especially in acid-base titrations and redox reactions. Remember, the equivalent mass is simply the molar mass divided by the number of reactive units transferred.